Hello, this is Dr. Naveen Sundar from Carnegie University, and we are going to see decision tree as we are discussing about the various algorithm. And today we are going to see about the decision tree. So first, let us see what is this decision tree is all about. Decision tree algorithm is a popular supervised learning algorithm. As you know, ML algorithm has two categories. One is supervised and another one is non-supervised. And here we are talking about the supervised learning algorithm. So here we have the training model. So it will support both classification and regression tasks. And we are mainly here we are working by partitioning the data into the subset. See, for example, here in this example, you can see the salary between this 50,000 to $80,000. If it is yes for a person, then we can say we are checking that offers whether it is near to home. Okay. So if it is no, then we are declining the offer. The next feature we are just think about whether we can provide the cab facility or not. Okay, so if it is yes means then okay, the next condition satisfied. Then finally we are going for accepting the offer. If it is no, we are again declining the offer. So this is how whether based upon the salary, yes, and then we are checking for whether the office near to the home, and then we are going for cab facility which is there or not, and then if it is yes means then finally we are going for accepting the offer. So we can say this is the leaf node and this is the root node and these are the left and the right node, and once when we come to this, it will become the root node and left and right. This is how we are just making the subsets and we are going to form the decision tree. Once if we set this, then if any salary coming between this, and then it will be easy for us to check whether we can go for accepting the offer or not. That's a main role of decision tree. That's why we are going to form such trees, and then we are going to train the tree based upon the values, and then finally what will be call it as a leaf node is we cannot do further classification, then we can say it is the leaf node, right? So that is how we are going to do it. So that's a partitioning the data into the subset based on the certain features. Okay, so that features only we are talking in this particular example. And then the partitioning is represent in a tree-like structure. As you see here, it is like a tree-like structure in which the root node and the left and right node, which we are having. The internal node that will be represented as the decision based on a feature. Each branch represents the outcome of the decision. So we can see that. So each node, we can tell it as like the outcome of these particular conditions, yes and no. Got it? So that is how we are making. And the leaf node represents the final decision or the outcome. Okay, we can see whether we are going for accepting the offer or not, right? Okay, so this is the decision tree. So for that, what are the things we are actually building is we can see here first we are starting the entire data set as a root node of the tree. Okay, so we know that root node is very important. For that, we are selecting the feature, right? So choose the best feature to split the data set. This is typically done by calculating the metric such as information gain. So we have a formula to find out the information gain for it. Okay, so we have to calculate, we have to choose the best feature to split the data set. Okay, so we have to find which is the best for the root node. Okay, so first that we have to find out. For that, we have to find the information gain. So information gain will be the maximum, okay, for choosing the root node. Okay, so automatically if the information gain is improved, then the impurity will be lesser. Okay, that will be equivalent to zero, we can say. As we traverse towards the tree, we can see finally there will be no further classification. So we can say that impurity becomes zero. Okay, that will be the leaf node. We will take it out. So each feature, so entropy we have to calculate for each feature we have to find out. We will see with the example that time you will understand very clearly. So the maximizing the information gain will be the root node and reduces the impurity the most. That will be the considered as the leaf node. So for that, how we are going to do is splitting the data set. Once a feature is chosen, split the data set into the subset based on the possible values of the feature. Each subset corresponds to the branch from the parent node. Okay, so that is how we are going to split. In the previous example also you have seen, right? First we are talked about the salary and then checking for the next feature, that is office near to home. And then if it's satisfied, then again we are going for whether the cab facilities can be provided. Okay, so if it is yes means, then we are going for accepting the offer. Until that time, the result what we are getting will be not be the final outcome. Okay, once all these features satisfied, then we are going for the final outcome. Okay, so that is how we are splitting and finally we will go and reach the leaf node. Okay, and then recursive partitioning, that means applying these two steps again and again and forming the left node or right node, that will become the root node again, and then we have to traverse across and form the left and right node. Likewise, this will continue until the it reaches the final outcome or it reaches the leaf node. Okay, so that's why we are saying that recursive partitioning. Again and again, it will be called. Okay, and to find the to reach the destination. Okay, so the leaf node assignment, when the recursion stops, that is assigning the class label in classification or a mean value in regression. So as I told you, it will support both classification and regression. So here we will call it as like a class label in classification, and in regression we will call it as like a mean value to each leaf node based on the majority class of the average value of the samples in that particular node. Okay, so this is the algorithm. So first we have to find the entropy for the entire data set. See, for example, in our example, we have 14 records. So that is the time we have to find the entropy for the entire data set. Okay. And then we have to calculate for each attribute or feature because we want to find out the information gain. Okay. For that, we have to find the entropy for each and every. So then only we can find out. So after finding the root node, then we can say, so the maximum value of the entropy of individual, we can call it as like the root node. And then when we go for the left node and right node, that is the time how we can select based upon the two. Okay, that is not only with the entropy of the individual element, but also we have to make the combination of the first element and the second element and first element and the third element. Likewise, we have to find out and find the maximum to put for the left and right node. Okay, so that is how for each attribute first we are calculating. Okay, so calculate entropy E of D comma X and information gain, that is gain of D of X for all other values. Pick the highest gain attribute and then repeat the 2 and 3 until we get the desired tree. Got it? So this is for the first one we are making, and again we are going for the repeating the same again and again until we reach the leaf node. That is the algorithm. Now we will find out how to find the information gain. Okay. So information gain means we can say that it is for a data set D, that is the main data set. Okay. So in the effective change in entropy after deciding on a particular attribute A. Okay. So we are calculating for the entropy of the complete data set. And then if you are finding with the particular attribute, so that is the time we have to, what we are doing is actually E of D minus entropy of D of A. Okay, so that is how we are just calculating. Okay, so that is A, how we are doing is we are just making which particular thing has the maximum, right? So that is how we are just subtracting, we are getting the information gain. Okay, so information gain for each every attribute we are calculating, and which is the gives the maximum result, that will be considered as the root node. Okay, so that is how we are calculating the information gain. As I told you, information gain will be always the maximum, right? So the information gain is the decrease in entropy after a data set is split on a attribute. So initially it will be maximum, and then once it is split, so it will be decreased, and then finally it reaches to zero. That means further classification cannot be done. Okay, so that is the final thing. Constructing a decision tree is all about finding the attribute that returns the highest information gain. Okay, so that is the most homogeneous branches. Okay, let us see with the example that time easily you will understand about how to calculate the information gain and how to calculate the root node and then left node and finding the leaf node. Okay, so this is the training set. We are just getting the data set in which 14 records, that is day 1 to 14, we are taking the outlook. Okay, so the outlook, what are the different parameters or different categories? We can say either it is sunny or it is cloudy or it is rainy. Okay, so three category of outlook which is there. And then depend upon the outlook, humidity and wind, we can say that whether the game is playing or not. Got it? So that is how we are just making, and then we are going to predict, will John play tennis on day 15 based upon these particular already available samples. Okay, sample data set in which rain, we are giving one outlook, and then, humidity that is high, and then wind is weak. So based upon these particular training model, we are giving the result to play whether it is yes or no. Okay, so the outcome what we are going to get is a categorical value. Okay, so A is either yes or no. Okay, so they depend upon these different features we are going to give, and we are going to give the categorical result whether play is yes or no. Okay, so how to calculate it? Okay, so first, as I told you, step one, we are calculating the um entropy for the data set, the complete data set D. So totally we have 14 records. Okay, totally we have 14 records, and in which we are going to calculate an outlook. As I told you, three categories we are having. Okay, so three categories of outlook, that is sunny, cloudy and rainy. And then we can say humidity, which is high, normal. Okay, and then we can say about okay, so either we are saying it's weak or strong, and then based upon that play is yes or no. Okay, so that is how we are going to calculate the entropy for it. So first, what we are doing is entropy for the complete data set D. Okay, so for that, what we are doing is here, the formula is E of D, that is minus Pi log 2 of Pi. Okay, so that is how we are going to put the formula. So how we are calculating actually here? So here out of okay 14, okay, how many yes and how many no we are going to calculate it. Okay, so for example, here in our example, no, 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 no. Okay, so that means five no's are there, and then you can see about yes or nine yes. Got it? Okay. So for the entropy for the complete data set, how many days we are playing? Yes. And how many days not playing? That is considered as the no. Okay. So nine, we can say yes, nine, yes, we are having. So out of 14 days, we can see nine is yes. So 9 by 14. And then no is 5. Out of 14 days, we can say 5 days is no. Okay, so we can say 5 by 4. That only we are substituting the value for Pi. Okay, so minus 9 by 14 log to 9 by 14. That is for yes, and minus 5 by 14 logarithmic of 5 by 14. Okay, so that is how we are substituting the value for Pi and Pi. Okay, one is for yes and another one is for no, because only two categories, right? Okay, so if it is three categories, for example, yes, no, and then if you are saying that partially yes and partial no, something like third category, if it is there, means that also we have to calculate, and the total number of days, and like that we have to make it as like a third one. Got my point? So here two category only. That's why we are putting it in a sigma and we are giving 1 to C. So it can be 2. If it is 3 category means 3. If the 4 category means 4. Likewise, we have to substitute n number of time and we have to calculate. So for this, the logarithmic value is 0.4097 and for this, the logarithmic value is 0.5305. Totally, we are getting the 0.9402. But this is for the entropy for the complete data set D. Okay. So coming to the next thing, what we are going to do is we are going to calculate the entropy and the information gain for an attribute. So each and every attribute we have to take and then we have to calculate. Okay, one is for the outlook and then we have to go for humidity and then we have to go for wind and then okay, so likewise one by one we have to find out the entropy. Okay, calculate the entropy and the information gain. As I told you, each and everything we have to calculate and which one is maximum, then we can consider that as the root node. Either outlook is root node or humidity is the root node or wind is the root node. Likewise, we are going to calculate. Okay. So first we are taking in terms of outlook. Okay. So in outlook, there are 3 categories. When you consider in the previous slide, you can see that in Outlook, there are 3 categories, that is sunny, cloudy, and rainy. So likewise, we are going to divide the outlooks. Sunny is one category, and cloudy is another category, and rainy is another category. Okay. So now we have to calculate like this sunny is how many times it is attending in the data set. So out of 14 days, 5 times sunny is coming. So that's why we are putting this PC value as 5 by 14. Got my point? This is for okay, 2 entropy. That is D for the whole data set, comma X. Another one attribute. Got my point? So first attribute we are taking outlook. Similarly, we have to find out for D, comma another attribute, that is humidity. And then D, comma another attribute we have to find wind. And we are going to find the maximum value. That is likewise we are going to calculate and we are going to put that as a root node. Okay. So now we are going for P of C, that is this particular sunny out of how many days. That's why we are putting 5 by 14. And then we are taking in this sunny, okay, how many times we can say yes and how many times we can say no. Okay, so we can say that out of 5 times, only 2 times yes coming. So we can say minus 2 by 5 logarithmic 2 of 2 by 5. And how many times no occurs of only sunny? So we can say 3 times. So we can say minus 3 by 5 logarithm 2 of 3 by 5. Got my point? So this is how we are calculating for sunny alone. Okay, this is for sunny alone. And then plus we have to go for the next outlook, that is cloudy. So when cloudy, how many times yes occurs? All the 4 times yes occurs. So 4 by 4. We can say yes is 1. Okay. And how many times no occurs? That is 0. So we can say 0 by 4. That's why we can say no is 0. Okay. Substituting here in this. So we can see that 4 by 14 into, okay, minus 4 by 4 logarithm to 4 by 4. Another one is 0 only. So we are leaving that. Got it? And then the next one is we can go for the next outlook is rain. So rain how many times occurs? That is we can say 5 by 14. Okay, as usual in the previous. And then out of that rain outlook, how many times yes occurs? 3 times yes occurs. So minus 3 by 2. Okay, 3 by 5. Sorry, minus 3 by 5 logarithm to 3 by 5 minus how many times no occurs? 2 times. So minus 2 by 5. Minus 2 by 5 logarithm to 2 by 5. So we are getting the value of this. So now we can add all these values. Okay, so entropy of outlook sunny, entropy of outlook only cloudy with yes and no. Okay, and then we can say of outlook of rainy, the play is yes and no. Got it? And this is like overall outlook of rainy by how many number of total days, that is 14. Got my point? So this is how I calculated for this thing, and just I'm substituting the logarithmic value using the scientific calculator, you can find out, and then we are getting the result like this. So now we can see that D, comma outlook. that is 0.34467 plus 0.3467. Got it? So I'm getting the answer as 0.6934. Now I have to find the gain. Okay, how to find the gain? Entropy of the whole data set already I calculated, right? In the previous slide, you can see I have calculated the entropy of D, right? So this value minus that particular first, that is E of D comma outlook. Okay, so this value I have to subtract. So minus 6934, I'm getting minus 2468. This same thing I have to repeat. Okay, so this I have calculated between the data set and the outlook only. In the same way, I have to find out between the data set and the humidity. Okay, and then I have to find out the data set and the wind. Okay, so let us see. So I'm calculating the entropy for the and the information gain for an attribute humidity now. Okay. So taking humidity alone. Okay, so clearly you can see about what is this. Okay, I'll keep here so that you can visibly see. So humidity alone, we can see that how many times, what are the types of humidity, that is categories. One is high and another one is normal. Only two category. In the outlook, we have seen sunny, cloudy and rainy. So three tables we have put. Here only two parameters. So we can say either high or normal. Got my point? So that's why two table alone we are getting. Got my point? So we can say that in which high, how many times occurring for 14 days, we can see 7 times. Okay, and remaining 7 times is normal. So that's why we are putting this 7 by 4, 7 by 14, and here 7 by 14. Got it? And then what we have to do, we have to go for in this particular high, how many times yes occurs. Got it? So that we have to find out. Okay, so 3 times yes occurs. So minus 3 by 7. Got my point? Minus 3 by 7. How many times no occur? 4 times. So that's why we are putting minus 4 by 7, 4 by 7. Minus 3 by 7, 3 by 7. Got it? So this is for the first humidity high. And secondly, for humidity normal, I have to calculate. Here, how many times yes occurs? 6 times occurs. So 6 by I have to put 6 by 7. So minus 6 by 7 plus 6 by 7. How many times no occur? Only one time occur. So minus 1 by 7 and plus 1 by 7, right? So this is how I can calculate for it. Okay, so just to substitute for the logarithmic value, I'm getting this and then I'm getting this. Okay, and then I'm getting this value for D comma humidity. So E of D already I have calculated 0.9402. For this information gain, I have to calculate. I have to minus this value with this value. How exactly I did it for outlook, in the same way I'm doing for humidity as well, right? So I'm getting the subtraction of this and I'm getting 0.1518. Okay, similarly for wind, I have to calculate. How to calculate for wind? Wind, how many categories are available? Weak and strong. So here also two tables only will be getting. Okay, let us see for wind. So now I'm putting for wind, weak and strong alone. Got it? So how many times weak occurs? 1, 2, 3, 4, 5, 6, 7, 8. So 8 times wind occur and 6 times strong. So I have to put, so how many times I have to make? So 14 divided by, okay, 8 times weak occurs. And here I have to put 6 times. Okay, 6 times strong occur. That's why 6 by 14. Got my point? Okay. And then inside the bracket, how we are getting in this particular week, how many times yes occurs? Okay, 1, 2, 3, 4, 5, 6 times yes occur. And no, how many times occur? 2 times occur. Okay, out of 8, 2 times is no. Out of 8 week, 2 times play is not happening. So 2 by 8. Got it? So I have to put minus 6 by 8 and plus 6 by 8 and minus 2 by 8 and here plus 2 by 8. Got it? And then similarly for this, I have to find out. For strong, how many times yes occurs? 3 times. No, how many times occurs? 3 times occurs. So 3 by 6, 3 by 6. So both we can say put minus 3 by 6 plus 3 by 6, minus 3 by 6 and plus 3 by 6. Got it? So I'm finding the logarithmic value of it, and then I know about E of D already, 0.9402, and then I have to subtract that value, and then I'm getting 0.048. Now I have to check the information gain for outlook is high or humidity as high or wind as high. Let us check. I can see that outlook is maximum. Okay, outlook is maximum compared to humidity and wind. Okay, so here 0.2, here only 0.1, and this is 0.0 only. Got it? So that's why I can put this outlook as the root node. Got it? So this is how the problem will be asked. Any table will be given, and then they will ask you to find out the entropy for each and every column, and then entropy for the whole data set. Okay, and then we have to find the information gain. Okay, so for information gain, you have to calculate, okay, with the data set and with the each and every attribute we have to compare with, and then finally we have to subtract with the whole data set and then find out which is maximum will be considered as the root node. Okay, so that is how you have to calculate. Okay, so that will be the formula. And then you can see that sunny and rainy. In Outlook, there are three categories. One is sunny and the another one is cloudy. And then we can say the rainy. Okay, so that is how this particular table which is formed. After forming it, then we have to go for the left node and right node, in which we have to take outlook and humidity. Okay, and outlook and wind. Okay, so likewise, we have to go for finding the left node and right node until, okay, likewise, we have to compare and we have to go traverse towards down, and finally there will be no category at all. All will become yes or all will become no. So such a situation comes, so that is the time we will stop it. See, in this itself, cloudy, all is yes. So further classification we cannot provide here. Okay, but for this and all, we can go for further classification because yes and no is available. Here also yes and no, which is available in category. So we can go for left and right node. But once if it reach like this, then this will be considered as the leaf node. Okay, so we will see the video. So that is, we will see the code. That is the time you will be very clear how to do the decision tree as well. Okay, all the best. Thank you.